Great. Are we live? Okay.
Yes, you are live.
Great. Well, good morning, everybody. This is Matt Kaufman, and on behalf of the Corridor Mapping team, we're excited to deliver this web seminar on troubleshooting mapping corridors using Migration Mapper. Jared Merkel is going to do all the heavy lifting this morning, and before I turn things over to him, I just want to give you a little bit of background on the Corridor Mapping team and how we got to where we are. Secretarial Order 3362 called on USGS to assist states essentially in mapping corridors. And in response, the U.S. Geological Survey assembled this corridor mapping team. And the mapping team is based primarily out of the Wyoming Co-op unit, which I am based at, and is sort of directed within the co-op unit program across USGS. And the primary goal of the corridor mapping team is to assist states to map corridors. We're essentially a technical resource. And I just want to introduce you to a little bit of the players here. Here at Wyoming, there's myself, Hall Sawyer, and Jared Merkel, who you'll hear from in just a bit. Matt Cuzacrio is a postdoc wildlife technician who's been working with us for about 1.5 years, mapping Wyoming corridors. And then in response to USGS funding from Secretarial Order 3362, we hired Holly Copeland, who's moderating today, and she's coordinating the mapping effort. And then Julian Fatbear, who's another postdoc at our shop here. And then other states involved so far. In Idaho, there's a new position, Jody Berg, who was hired as of February, jointly funded by USGS and Idaho Fish and Game, and also Tristan Nunez. Jody's mapping empirical corridors and Tristan's doing modeling work. In Colorado, we're working to map corridors with them, mostly working on cartography. Nevada has shared several, or about a half dozen, their mule deer corridors, which our group has been working on mapping. And then Arizona, next week, Lucas Olson will start in Arizona as a position jointly funded by USGS and the Mule Deer Foundation, and he'll be joining the corridor mapping team once he gets on the ground. And the work of the corridor mapping team is really essentially a response to Secretarial Order 3362 to provide this technical assistance to the states. It's funded primarily by the USGS through the co-op unit program, but also with funding from the WAFWA Sagebrush Science Initiative, which is itself funded through the U.S. Fish and Wildlife Service, in addition to several private foundations. And so about, I guess, maybe 1.5 years ago, maybe longer, we built the Migration Mapper, recognizing that a lot of people who needed to map corridors weren't proficient with R. And so Jared Merkel was the architect behind Migration Mapper, at least all of the R code. And about several months ago, we were talking with Utah and realized that they had requested essentially a sort of a 2.0 tutorial on corridor mapping. And since our group has been in place since January, we've been mapping Wyoming corridors, but also looking at Nevada corridors and Idaho corridors. And so we've really been sort of testing the Migration Mapper against all sorts of different data sets. And we've spent a lot of our time just problem solving and troubleshooting different data sets. And we recognized in this conversation with Utah that probably a lot of those problems that we've been troubleshooting are things that other people around the West who are mapping corridors are encountering as well. And so the goal of this webinar is to essentially walk through Migration Mapper, and specifically Jared's going to hit some of the main problem areas that we have come up against and some of the solutions that we've used to overcome them. And so with that, I'm going to turn things over to Jared, who will run the rest of the webinar.
All righty. Hello, everyone. I hope you're having a good day. I hope you're sitting back, you have a cup of coffee, and you're going to enjoy this. Maybe have a notepad next to you so you can take some notes. But I know it can be a little awkward on the webinars, but just bear with me. I'm going to share my screen. I have some slides to show you. I'm going to show you some demos, and basically we'll have some fun. And just to reiterate what Holly said at the beginning about some kind of logistical things, everybody's on mute. When you came in, you're on mute in this. And if you have a question, we would rather you text in the group chat area and just say, I have a question. And then Holly will unmute you or kind of facilitate questions in real time. The alternative thing is you could actually type your question into the group chat, and Holly will compile those over the course of the workshop or the webinar. And then towards the end, we can kind of field some of these other questions that came up throughout the webinar. And so let me share my screen here to get us started. Holly, can you verify my screen is shared? Okay, we got a verification over here. Okay, so just to, let's see here. Just to reiterate, this is my plan of an agenda. I'm going to give you a brief overview of the methodology. I feel like it's very important that everybody kind of understands conceptually how the methods work. Then I'm going to show you very briefly Migration Mapper. Not going to show you all the details, but at least show you some of the specific things that have to do with some of the common problems and issues that we have with working with Migration Mapper. Then, as most of you saw from Matt Kaufman, we basically generated a list of the most common questions and problems in mapping corridors. And I am going to basically go through those questions one by one, show you some slides to kind of illustrate how we go about answering those questions. And then finally, hopefully I'm sure we'll have some time towards the end to field questions from everyone as you type them into the group chat, and Holly Copeland can organize those. So let's get started right now talking about the BBM method. And so really what I want to show you guys is how we get from this idea of a winter range and a summer range and the connection between the two by mapping these migration corridors. So it usually starts out with a bunch of GPS collar data, and that's the basis of everything that we do. Oftentimes it looks like this. Down in the bottom right, I think you guys can see my mouse. This is the winter range of this population down in here, and then up in here we have the summer range of this population. And the question really is, what do we do with all these dots on the map? And the first thing we can really do is connect those dots with a line, and that helps, and that's useful, and we can start to think about this connection between a couple things. The first big question that really kind of drove the initial development of mapping corridors 10 years ago with Hall Sawyer and Matt Kaufman is, how wide is this corridor? That question really drove us to make this step and figure out how to map corridors. And the biggest question is, a line has no width to it. And especially, we often have multiple lines per individual. And so I just showed you a fall migration. Now I just showed you another spring migration and another fall migration. In addition to these multiple migrations, we also have other individuals in the population. So there's one individual in black. And that we have to be able to, and so at the time, 10 years ago, we basically had no means to combine those routes to make any population inference. And we really had no idea how to quantitatively measure where on the landscape these animals spend the most time. And so that's really the basis for the methods that I'm going to show you. And that really brings us to the Brownian Bridge movement model. Now, before we jump into that Brownian Bridge movement model and show you how it works, the first thing we have to do is identify the migration sequences. And the way we do that is by plotting what we call net square displacement. So what you see here is time on the, so usually starts on winter range, And you basically calculate how far the animal gets from a starting point. And in this case, it'll be in the middle of winter, how far away it gets. And what we can see with this type of graph is we see that at about this point in time, the animal starts moving away from its winter range and arriving on its summer range. And then it spends time on its summer range, comes back, etc. And so what we do, and what you'll see in Migration Mapper, is we pair these graphs, which is a measure of how far an animal moves away from its starting point across the year, with maps of the animal on the landscape. And so once we do this, we can actually isolate the data during that spring migration or during that fall migration, and then we move forward with the Brownian Bridge movement modeling. So what does the Brownian Bridge movement modeling do for us? Well, it basically connects the dots and uses a statistical model to generate a heat map of use. And so the dark spots on that heat map are where the animals spent a lot of time, and the light spots are where animals did not spend much time. And so what this Brownian Bridge model does for us is it gives us an estimate of where the animal might have gone between points in time and what the probability or the heat map of use over time for that migration route. So that's essentially what the Brownian Bridge movement model does. And so what you can do then is you can calculate a Brownian Bridge movement model for each migration sequence. So I just put the fall migration on there. I can put a spring migration as well, and then another fall migration. And once we have these heat maps for each migration, we can then stack those together and average them to create a heat map of that individual animal with all of its migration sequences combined. So that's the Brownian Bridge movement model in its essence, and average together to create one individual's movement model. Okay.
What's the issue?
Maybe having sound issues, just hang tight, folks.
Hey, Jared, we're monitoring it. There's just sometimes when you're kind of breaking up just a little bit. I'm not sure at this point that it's bad enough that we need to do anything about, but just want you to be aware we're monitoring it.
Okay.
Speak up.
Just yell louder.
Yeah.
Okay. So should I continue? Okay. Okay, so that's the Brownian Bridge movement model averaged together for an individual. Now we have a heat map for a given individual in a population. Now what we can do with that individual or at the population level, we can calculate stopover sites. Time, which we would suggest as important for that animal. And in this case, we calculate the stopovers as area about 10% of the area of the footprint of the individual, or the top 10% of the values. And you can see in blue here, it's all the little areas where the animal spent quite a bit of time. So that's kind of how the stopover idea works. And I'll explain it a little bit more in a moment. So the next thing I've been telling you about an individual, but now we have to think about how do we go from the individual heat map to a population heat map. So I just added another individual's data in blue. That can be turned into an average heat map. Here's another individual in green that also can be turned into a heat map using Brownian Bridge methods. And we can then stack up these individuals and average their heat maps up together to create a population level heat map of where the population goes. And so what I just plotted here is the data from a huge number of animals over more than 10 years. And to distill this into a couple of maps to map the migration corridors, we first create the Brownian Bridge for each sequence, and you'll have the steps here listed right here on the left. We create the Brownian Bridge for each sequence. We average those together within an individual, and then we average each together to get a population Brownian bridge or a population heat map. And what we can do with that population heat map is first take that top 10% of the values, and those are the stopovers. Those are the most important places on the landscape where the animals spent the most time. Now, if we want to actually map the migration corridors, we have to alter how we stack up the individuals slightly. And what we do now is instead of focusing on the heat map, we focus on the footprint for each individual's heat map. Now you just see where the animal went, and it's merged together its spring and fall migrations.
Repeat that first information, that last information, sorry, from the beginning of that slide.
Wow, so there's really, so it's my computer having this problem? Is it
Yeah, Jared, I'm wondering if maybe it's the streaming from that room, and I'm wondering if maybe you call in on a phone, or somebody could do that for you while you're talking, and then pass it over to you, and then you know how you can do that.
Yeah. I'm amazed by this.
I know, I am too, but I think that would be the most reliable to just switch over to calling in on the Zoom.
Okay, can we use somebody's? Yep, I could use mine if somebody just calls me in. Okay, we're going to take a quick timeout and fix the.
Yep.
The.
If you, it's pretty easy. If in the lower left corner where you see the audio for your Zoom call, if you click on that up arrow, you should see an option to join by phone. Did you see that?
Oh, well, they're just going to call me in. Is that good enough? Or?
Okay. Yeah, you can do that too, or you can just say switch to phone audio and then do it that way. Well, I'm already doing it, so it's.
Okay, I'm going to mute myself for now, and then I'll come on with the
Okay. Okay. Thanks, everybody. Hang on while we get this audio issue fixed. Sorry.
Potentially it's the weather. It was like 12 degrees this morning in Laramie with the wind chill, and right now there's snow going sideways. So
Okay.
Bear with us.
Bear with us.
All right, I can hear you loud and clear now, Jared.
Well, it's still his computer.
Oh. Look at this question.
Okay, folks. Can everybody hear me?
Yes.
Holly, can I
can
verify that you hear me?
I can hear you. Yep. Thank you, Jared.
Okay, great. I think we're set to continue. So, right, we were just transitioning from how we calculate stopover areas to now calculating population level migration corridors. And so what I was showing you is in the population level analysis, instead of focusing on the heat map of where animals spend time, we focus on what we call the footprint. So basically the contour around that heat map. And so, and you can see in this orange animal here, we have multiple migrations merged together to create one heat map or one footprint for that individual. And basically we have some steps in the same manner as before. So we create a BBM for each sequence, we average them for the IDs and create that footprint. And then we simply stack up the footprints for each individual. So I just showed you an individual in black, the footprint, and now an individual in purple footprint. And then what we get when we stack those together is this map of basically the percent of the population using the different routes on the landscape. And in the darker blue here, we have more animals using this area versus the lighter blue, fewer animals. And then the lightest blue is only just one animal using this. And so what this allows us to do is now calculate the percent of the population that's using any given migration route. And this could help us identify those main corridors. And so I just want to reiterate, because I think this is very important, is the methods of how we get stopovers. And I'm going to say the corridors next. So again, for stopovers, we take each sequence of migration, calculate that Brownian bridge movement model, average those Brownian bridges across the sequences for a given individual. So we have one heat map for an individual. Then we average each individual's Brownian bridge together. And then we just carve off that top 10% of the values. And those are the most important places in the landscape, which we call stopovers. Now, if you compare that to the high use corridors, basically what we have here is we still do the Brownian bridge for each sequence. We average them for an individual. So we have one Brownian bridge for an individual. Then we create that footprint, which is that contour for that individual. And then we simply stack up those footprints. And with that stack of footprints, we can calculate the percent of the population that's using any area on the landscape. And we often calculate anywhere that's more than 20% of the population that's using a given area is a high use corridor. And anything more than 10% of the population, we say a medium use corridor. Okay. Oh, and the last thing I want to mention is these very similar methods can also be used to delineate core and winter ranges and core winter ranges. And so this is just an example in northern New Mexico of probably nearly 500,000 GPS points just on winter range. Obviously, this just looks like a big blob, but once we do the same exact methods, we can calculate this average utilization distribution or kind of heat map of where animals spend time. And now we can start to identify where those core use areas are, or the more important areas. So everything I just explained to you is implemented in Migration Mapper. And basically, that's the next thing I'd like to go into next, is giving you a quick tutorial on Migration Mapper. And just heads up, I'm going to be quite quick through the details, but I'm going to stop where a lot of the questions come up and where we have to make decisions about mapping corridors. So I'm going to switch sharing my screen, and so maybe Holly, if you can let me know if we're good to move on to the next section.
Yep, you're good. Can you hear me, Jared?
Yep. Just give me one second here.
Okay. We did have one question come up, but it's not a technical mapping question, so I think I'm going to save those for the end. It's more a general question.
Okay, that sounds good. Okay, so Holly, can you confirm that you can see my screen with Migration Mapper on? Okay.
Yep, I can. You're good.
Great. So this is what you see when you work in Migration Mapper at the very beginning. A little bit of information, a link to the user guide. You get started. Now, the first thing that happens in Migration Mapper is you have to choose a folder where your GPS data are stored. And those GPS data need to be stored in a shapefile with a column for animal ID and date and time of the GPS location. Either you can have one shapefile with all the individuals combined, or you can have multiple shapefiles with each individual's data in a separate file. It's set up to do both. So I have a folder here with some of our sample data, and I'm just going to bring in a couple of individuals from our sample data to show you how it works. So I'm bringing in 3 individuals from our sample data. I'm going to click Begin Import. Then it asks you find an empty folder where we're going to put the Migration Mapper project. And then it asks me if there's an animal ID column to identify each unique animal ID. Now, before I leave this page, I just want to mention that down here, there's also an option to resume an existing project. So if you get through Migration Mapper to a certain point and need to go home or the computer crashes, which sometimes happens, you can always go back, reopen Migration Mapper, click on Resume Existing Project, point it to the folder that you started before, and it'll come back and pick up where you have left off. So I won't show you that in detail today, but that is very possible. That helps you also with, let's say you pick migration dates and then you have a discussion with a local biologist or somebody on the ground, and you might want to change some individuals and how they might, and where you identify their migration. You can go back, reopen the project, fix those, and then rerun the Brownian bridge analysis. Okay, so I'm going to click Execute to go to the next page. The next thing it asks me is to select the columns that have information about dates. So I have a column that has the date and a column with hour. And then it tells me, it asks me, okay, for the date column, how are the dates organized? And in this case, we have year, month, day. And then for the hour column, it's simply hour in the 24-hour format. I know these are in Mountain Time. And then I click Process Date. And Migration Mapper does a huge amount of things now. It checks for bad points, unreasonable speeds, if an animal is dead or the points are sitting in one location for more than a certain amount of time. It'll flag those, and it does a lot of things just to help you quality check. It doesn't do everything, but it can help you at least understand a little bit if you have some problems with your data. And this tab 4, this import results, will give you some information about what you just did. I've imported 3 unique individuals. Looks like there was one row in my data that had an NA in it. And so that NA was removed from the database. So once you get through this, there'll also be, if there's other issues, that'll be listed here. Now, once you're done here, is when we get to selecting migration dates. And this is the most time-consuming part of the process and one that you have to put the most amount of thought into. And this is the setup for the screen here. And so basically you have an individual year. So this is animal 317 for year 2007. And so you're going to flip through every animal year in your database and select migration dates or not. So on the left here we have, is there a migration or not? Is there a fall migration or not? And then you have these sliders to help you select the date. And so this is key to what we do here for finding migration. So you can move these sliders. I'm going to start with springtime. Bear with me for just a second here as we move these sliders around. And so basically what we're doing here is selecting this spring period. And as we saw before in the net square displacement, we have the animal moving from its winter range up to its summer range. And the great thing about this system is we have a couple of key features here. So the first thing is I can move this map around, I can zoom in. And on this map over here, each dot represents the first point per day. So not all of the data will be plotted in this map, but the first point per day. And so oftentimes that'll be something in the middle of in the early part of the night. And so what we can see here is there's 3 days of data on this winter range before we start moving this migration outward. And so anyway, I encourage everybody to use the sliders and using this map to help you decide when the migration starts. We also have this tab called NSV Spring, which zooms in to that spring period, and you can really see. And so now I can see that I have 3 days of data on winter range before the animal starts moving. And so what we often do is we want to make sure we have at least a few points on the winter range and on the summer range before they start migrating, because we want to make sure that it starts on the winter range, the migration corridor or the migration route. And so what this can allow you to do is think about, okay, so this blue point is the first point of that day, and so there probably is a few other points on the winter range before it moves off. We can also go up here, zoom in on the summer range. Oh, and we can see we haven't quite made it to the main summer range with where we're at. And so I can move this slider to the right one. And I did that by clicking on the button and then pushing the right arrow, which allows you to move the slider 1 notch at a time. Sometimes it's hard to actually use your mouse to slide. So now we can see that we have points all the way into the beginning of this summer range. Okay, now let's work on the fall. So let me get it pretty well figured out here. Holly, are you guys able to see the updates pretty well on Zoom?
Yeah, for me, for us, it's working great.
Okay, good. Okay, so now the fall migration is in purple, and so we can see we have 2 days of data on this summer range. And then now the animal is moving away from summer range. You can see it does a little bit of loop, backtracks just a little bit, and then continues down pretty much on the same exact route, a few deviations, and then back to its winter range where it ends its migration. So really this is the way we select these dates. There's also a satellite map if you want to get into detail of where the animal is spending its time on the landscape. This can help you make those decisions. What else is really useful? So another little trick here is once you have the date selected, instead of moving these dots, you can actually move the whole slider. And as you move this, and I think my internet is pretty drained right now with everything, but the map will update as you make that slider move. And so you can actually kind of get a feel for where the animal is moving across the landscape using these sliders and moving them this way. Okay, so then what you do once you're done with this animal, and I'll just try to move it back here so it's fairly correct. Go to the next animal, and now you have another migration. And we do the same thing with this, and go through each one of these. And I'm just gonna quickly do this. One thing to note, if there's no migration, let's say the animal died or the animal wasn't collared till the summer, you can simply put no spring migration present, and that'll comment out these bars for the spring. You do the same for fall. So you have to identify this for every animal year in your data. Okay, so once you're done with this, I just have 3 animals here. You then, I'm quickly doing this so we don't spend too much time on it. You then have basically all your dates selected, and you will next be going on to the next tab, which is to calculate and run the Brownian bridge analysis. And so this is where might take a little bit of time, but it's all set up. There's a bunch of parameters here in a different tab. I'm not going to go through them, but that can give you an idea of if you want to do parallel processing, or if you want to change the raster resolution of your data, etc. That can all be found over in this analysis parameters tab. Now, before we move on, I'm going to exit out this one and open up a project that I've already been doing. Oh yeah. I'm getting a little tidbit from somebody else in my room that we have created an extensive user guide that's very useful. So if you have any questions about Migration Mapper, you can go into that user guide and you can literally just search for words or keywords. There's a troubleshooting section, anyway, anything. So can you guys still see my screen? Okay. So what I've done here is I have imported another project that I'm already finished with. And you can see here there's 73 animal years in this data set, and I've already gone through all of them, picked migrations. We've run the Brownian Bridge analysis. So here you can see this is what all the migration corridors look like, or the migration routes look like. Then we have this tab 7, which we call the animal grouping tab. And so this is the next, or one of the big decisions when you're mapping migration corridors, is to think about what is the population that I'm mapping, and is there two populations here or one population? And it's an important thing, and I'm going to talk about it later. But the point I want to make here is that you can group your animals into different herds or populations in this tab if you would like. And so in this case, we've basically put this north herd or north group of animals into one population, the central into another, and the south into another. And so that's mainly just for illustrative purposes for you guys to see that this is possible, that you can split up these animals. There's a pane for winter ranges and how to do the same thing for winter ranges. I currently have it not conducting winter ranges. You can say yes or no to winter ranges in Migration Mapper. But you can also do these same things, and the same thing about grouping the animals in winter range as well. And then basically we have the final corridors. These are all done here, and you can see that, I know it's kind of messy here, but there's one here, and then one down here. And we have a low use, medium use, high use corridor, and stopovers for each of these groupings. Okay, so that's a quick and dirty rundown of Migration Mapper. I hope that's useful for everyone to kind of just get a feel for how it flows and what we do. I now want to go back to my presentation and continue with that. Yeah, let's pause and see if there's any questions or to talk about Migration Mapper. And I'll wait to share my screen.
No questions have come in yet, Jared, on Migration Mapper specifically.
Okay, I think that's fine. I think we'll, some of the things I even mentioned in Migration Mapper, we'll be digging deeper into them here in this next section. So some of those questions might be answered if folks have them kind of rolling around in their head.
We did get one question from Phil Walker. Can you export the BBMM calculated in Migration Mapper as a shapefile? Or raster? But both are produced.
Let me, yeah, it's kind of tricky to share the screen, but in the project folder for Migration Mapper, you're going to have a number of other folders inside of there. And there's going to be, the Brownian bridges are going to be all saved as rasters. And then the final products will be saved as shapefiles. And so that's what we've been giving you as the individual Brownian bridges are raster files, and then the final corridors and stopovers will be shapefiles. So yes, you can get all that information from your project folder, which, as you can imagine, could get quite large with all those rasters being saved.
Okay, I think you're good to move on.
Okay, so
questions coming in.
Jared, a couple other questions popped in.
Okay.
Do you want me to field them real quick to you?
Sure. Yeah, I think that's fine. If they're related directly to Migration Mapper, let's do that.
Yeah. What is the ideal? Well, yeah, some of these I think we're gonna talk about, but what is the ideal time spacing between two successive points when programming callers in order to be able to use BBMM? Some of our older caller data collected 1 point per day. This doesn't seem to work very well with BBMM.
Yeah, I'm going to get to that in a little bit, and let's hold off, and I'll answer that question when I have a couple slides up.
Okay. And then there's a sort of a related question about irregular and uneven data, and data like Argos data with a lot of gaps.
Yeah, let's get to that too when we start getting into this next section.
Okay, great.
Any directly related to Migration Mapper? Okay.
No, those are the only. Yeah.
Okay, good. And I know that was quick, so folks that have never used Migration Mapper, that was probably too fast, but those of you that have been at the workshops that we gave, I just wanted to kind of give everybody a quick overview so we kind of are on the same page with how that program works. Oh, and I got another tip to make sure to use the user guide. It's a very good resource for a lot of the questions we have with Migration Mapper. Okay, so basically the next part of this webinar, we'd really like to dig in and discuss some of the common problems that we and other folks have brought up about mapping migration corridors. And a couple of things I want to mention to you guys before I kind of dive in here is, one, a lot of the maps that I'm going to show you are for illustrative purposes. I'm not going to say that it was the exact thing that we ended up doing or not. A lot of the maps I'm showing you are for illustrative purposes. And I also don't know, I'm going to show you maps that I don't even know a lot about the data themselves for those specific maps. And so I just want to give you that caveat that I'm going to be saying some things about maps that are based on how we think through the process of mapping migration corridors. The other thing I want to mention is that a lot of the common questions that come up, the answers are not always black and white. And what our team has learned to do is to work together to make those decisions, make sure we have somebody from the field talking to us, looking at the maps as well. And so we often make these decisions collectively, and we weigh the pros and cons of different decisions. And we just make those based on putting our biology caps on, if that makes sense. And so I just want to give you kind of those broad initial things before we jump in. So the first thing that's a big question and a very important thing for mapping corridors is defining a population or a herd. And I want to kind of dig into this just a little bit to make sure that this is clear for everybody and why it's important to make sure we think about how we define a herd, a population or a herd. So in many cases, this can be quite easy. And that's because oftentimes to study a population, we often go to winter range. Animals are clustered in a potentially a discrete winter range, and we do all of our captures within that one winter range. And that is obviously the easiest way to define a population or a herd. And then basically what our analysis will do is tell us where are the migration corridors and stopover sites, at least the most important migration corridors and stopover sites, emanating from that given winter range. So that's the best way to think about it, and that's the kind of common way and the way that it's clearest. Now, oftentimes we don't have discrete winter ranges. Animals are wintering across a whole, let's say, front range of some mountain range. Things can get trickier, and I don't have all the answers, but I want to just tell you some of the thought processes that we have. And so this is a population of elk east of Yellowstone National Park. They winter down here by Cody. And we captured a number of animals across this front range, and you can see in brown are the winter ranges. And so some of the decisions that we had to make were with all these lines, so all the lines you're seeing are the migration corridors and migration movements. We had to make this decision, is this one big population or is this multiple populations? And so I just want to show you guys some of the ways we think about making these decisions. And so one of the first things is there any kind of natural break in that winter range? And so one thing that we noticed is these animals do not cross the South Fork very often. And so that was one kind of natural break that we could use in this population to decide if there's two different populations. Another thing we think about is how much movement between the winter ranges there are, and you don't see much between these, but there could be animals that switch, spend winter one year here and then winter in this area and another year. And so if we have these animals switching between two relatively close winter ranges, oftentimes we'll lump those together because the migration corridors emanating out of those will be from a common, at least more common winter range based on the individual. Another thing that we think about is sample size. And so one thing that you have to watch out for when the population is spread out on a winter range is, have you potentially sampled way more in the northern part of that winter range than the southern part? And if you combine that whole winter range together, that uneven sampling is going to create an uneven bias towards thinking that that migration in the north is more important than the migration in the south. So I hope that makes sense in thinking about sample size. So those are some of the main things we think about when defining a population of a herd. It gets really difficult. Another thing to mention I forgot is sample size in itself, and we'll talk a little bit about this. But when you're trying to do a 20% corridor, a 20% high use corridor, that's 20% of the population. So if you only have 10 callers that you're using for a population, that means 2 animals will define your high use corridor. And I think many folks would look at that and say, well, that's not very many animals to define what we would think of as a high use corridor. And so when you're breaking up winter ranges or just defining a population or a herd, you also have to think about sample size as well. You don't want to just have 10, 15 animals representing each of your corridors, because you're now having problems with stochasticity in your sampling, et cetera. And so these are all the things we think about when defining a population or a herd. Hopefully that makes some sense. Does anybody, I'll just stop here for just a second. Does anybody have any specific questions along those lines? And in that sense?
Jared, I haven't seen any questions come in on that specific topic.
Okay, that sounds good. Okay, so that was defining a population or a herd. The next thing we have to do is define migration. So we have to identify these migration periods of time, or the data that represent the migratory period. And so the way we've kind of thought about it here in our group is that migration tends to be seasonal movement, tends to be back and forth movement, so going up to one place and then coming back to the same place as before. That's an important thing to think about, especially for an animal that's nomadic and is moving all over the place. That's really not migration, but it is, we could think about it in certain ways, and we can talk about that in a little bit. So it's seasonal, back and forth movement, and the biggest thing is it's movements that connect distinct seasonal ranges. And so that's the idea here, is that migration corridors are important areas that animals use to connect seasonal ranges. And so what you're seeing here on my slide is a beautiful mule deer migration. I know we've had some jokes about this, that not all animals do this, but this is a perfect example of an easy way to define this. So this animal has a very clear, distinct winter range. At some point in I think late May, it leaves that winter range and migrates up to a very distinct summer range. And at some point towards, looks like early October, it leaves that distinct summer range and comes back. And so in this case, this is the easiest way to define migration. And just so you know, the next few slides are going to be all about thinking about defining migration and how we deal with animals that do not conform to this quite simple migration pattern. Okay, so the first thing that, first question I want to kind of think about when defining migration is, how do you define when the migratory movement starts and stops? And so, as I showed you when I was demonstrating Migration Mapper, we tend to grab the last day of points before it leaves its winter range. And so we want to make sure that we have some points on the winter range, and then it leaves, moves up to its summer range, and then we want to make sure that we have a few points or a day of points on that summer range as well. And so that's the first thing that we make sure we have, is that we have a little bit on the winter range and the summer range. Now, when the winter range and summer ranges are not as distinct and clear as this, it gets a little bit trickier, but that's why we have the map next to the net square displacement. And so you can zoom in on the map and look at how the animal is moving on the landscape. For instance, sometimes we see animals that right before spring migration, they might move a few miles and then have kind of a little secondary stopover, and then they continue moving on. We include that. I mean, this is a part of the movement between that main winter range and its main summer range. So that's that question. And then here is a zoom in picture of the spring of, I think it's this animal. I can't remember if it's a different animal or not. But so the point is, again, we can zoom in on that spring migration period, and you can see here that we've included a day of data here, and then it starts moving, it gets far away, and then gets up to its summer range here, and then it spends we have about a day of data collected on that summer range as well. And I've zoomed in on the map here to help facilitate you making the decision of when that migration is starting or not, because the net square displacement is not always clear as a bell. Okay, so those were mule deer. Now let's look at an elk, which, as many of you know, don't have quite a bit more movement, a lot more stochastic movements. In this case, we see a much more messier movement, but it still clearly is a migration in the sense of our definition, whereas we have the winter range in the north here, and then it migrates south to a summer range, and those two ranges are distinct. You can see that once it leaves this area in early May, it basically never comes back to it all the way until mid-October. So in our case, when we look at this, we want to know, when does it leave that general summer range area, and when does it arrive on that general winter range area? And so in this case, just to look at this fall migration, even though it looks quite messy, we would include this as migratory behavior. Now, obviously, this is not going to create that skinny little corridor. It's probably going to be more of a blob and a wider corridor, but that's technically the definition of migration, and technically this is what they use. This is the area they use to move between those two seasonal ranges. Another thing to note with this, and we'll talk about it more later, but maybe it's hard to see on your end, but this collar is collecting quite a few points in here, so you see a lot of green. And then suddenly, starting in April, you'll see the collar goes on like 1 point a day and gets quite sparse. And then somewhere July 1st, it looks like it starts collecting quite a bit of data again, and you can see lots of colored points. And so we're going to talk about this in just a little bit, but I want to just bring up that you can see from this simple graph how much data, or if the data are poor or good quality when you zoom in here. And let me go back just to zoom in on this. You can see, so when you zoom in on the spring migration or the fall migration, each vertical line is a day, And so I can basically count here that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe 10 points that are collected that day. And so you can kind of get an idea that this animal has probably a 2-hour cycle for it. And so, but if you only see one dot per vertical line, you can see that the caller is failing, or if you have a life cycle call, you can see that in the data. And we'll get to some of these questions a little bit. I just wanted to show you that with this graph, you can look at those. Okay. So another big question about defining migration, and elk often do this, even in Wyoming, is they would be on summer range and they actually go down to winter range, check it out or whatever they're doing, and then they go back up to summer range a few times. So this is a tricky question here. It kind of starts to develop, it starts to violate the general definition of migration. But we have been including animals that do this a few times as they're still migratory. There's still two distinct seasonal ranges. There's this summer range up here and there's this winter range here. And they only went back and forth a couple times. Now, if the animal spent its entire year going back and forth, then we would probably talk about that animal as a resident animal. But we've had a lot of discussions about this, and like I said, it's not black or white, but we tend towards when it looks like this, when there's a clear summer range and a clear winter range and only a few movements back and forth, we'll tend to still include this animal as migratory. Now, the next thing that we've been doing, and it's just based on discussions that we have here, is so the one thing you have to do is you have to choose one of these to bring into your corridor mapping. You probably don't want to conclude all of this into the Brownian bridge analysis. And so what we've been doing as just a definition, and what we've been trying to keep consistent, is we grab the movement corridor or the movement route of the first time the animal leaves its summer range and comes down. We figure that might be maybe the animal is making its decisions free of hunting season. So it's my understanding that a lot of this type of movement for elk in Wyoming has to do with hunting season. So they might come down and then maybe hunting season starts and they'll move back up into summer range in the higher elevation, stay there and check. And so that's one of the things we think about. Now, when we're also deciding what migration corridor to pick, some other things that we think about are route fidelity. So we can see on the map here that every time this animal goes back and forth between these two ranges, it's basically using the exact same route. So this is nice because we can just pick one of them. We can pick one that has the best data, or maybe one that has the most linear movement, and so we can kind of figure out the main route. So that's one thing we think about, is route fidelity. Another thing that we often think about is, does this individual have another year of data that's a little bit cleaner and clearer, and thus we could use those migration routes from a different year of data and maybe just throw these out, especially if it's using generally the same area. So anyway, those are a couple things that we think about when deciding which route to include. The fidelity of the route, whether there's another year of data for that individual that has a cleaner movement that makes a little bit more sense, et cetera. So hopefully that's clear, or at least generally clear of our thought process. Obviously, at some point, one just has to make a decision and include one of them or not to move on. Okay, another thing that comes up quite a bit is stepped migrations. And so in the fall here, we see this for this animal where it moves down, spends a few weeks, moves a little bit, spends a few weeks. This often happens in the spring as well with stopover sites. And so it seems like most of the studies are showing that these animals are moving in spring in concert with green up progression. And so they might move a few miles, stay in one site, wait for the green up to occur, move another few miles, stay in one site, exploit that green up, et cetera. And so these step migrations, we generally include all of that as long as that movement is connecting the two seasonal ranges. Now, one thing you have to think about though is if that stopover is like 2 months, then you might be thinking, okay, that stopover is a huge amount of, they spent a huge amount of time there. That's maybe okay, but it also might influence how your the footprints and the stopover areas are identified, because the animal spent so much time in that one spot. That's going to seem like a hugely important spot compared to the other parts of that migration. So you have to think about, when you're deciding whether to include a very long or large stopover into the analysis. Now I want to show you a couple other things with this graph here. And so the first thing, this is the main winter range down here. And we can see that the first thing they do is they just move a couple kilometers, and then they spend a few weeks here. And so this is a typical stopover. We include these in the migration route, so the animal gets from here, moves on, and then continues after some time. And so you might, I mean, I could see some people thinking of this, especially in the fall, it spends nearly a month here, is this might be more like a extended winter range. We talk about these things amongst our group. Is this an extended winter range, or is this a stopover area? And we tend to lean towards calling these things stopovers, so we make sure we're connecting the entire route or corridor between these distinct ranges. Because if you started the migration here, then you would miss this connection between these two, miss the connection between these two kind of clusters of points. Another big decision is, we see that this animal went up to summer range and actually overshot its summer range and then spent a couple weeks and then came back. This is kind of a tricky thing, whether or not to include this type of data. We think about it as, is this area important to the animal, or is it at risk of development, or some of the questions about that? We'll think about those questions. We also think about, is it easy for us to just extend that migration corridor so it includes it without too much extra data into the spring migration? In this case, we didn't include it because basically it doesn't seem like that important of a spot, because they just went past their summer range and then came back and then never went there again. But anyway, those are some of the thought processes that we discuss amongst our group when we're deciding what aspects of that movement do we include as migration, etc. Now, the last thing I want to mention is, if you in your state are also going to be doing winter ranges as well, I think that you can be a little more lenient in not including as much in the migration at the start of the spring migration and at the end of the fall, because you know that data will be collected in the winter range analysis. So that's another thing you can kind of balance when you're making decisions about what to do for a given migration, is if you know that you're also going to conduct that winter range analysis, you could be a little bit more conservative on whether or not you keep the data at the early in the spring or late in the fall. Okay, let's let me continue with this graph. I guess I already had shown you this. I talked about this. I forgot I had this slide in here. So this is just reiterating, there's that kind of second little summer range there, and you might want to think about whether or not you include that movement out to that or not. And then, like I was just saying about the stopover versus the kind of second wintering area. Okay, so here's another one I want to show you about more of that long stopover idea or issue. And so this animal winters down here and then moves here and spends, I think, nearly 2 months on this stopover. And so in this case, we would include it, even though it's quite a long stopover, because it is clearly part of this connection between this main dense in that animal's heat map, because it spent so much time there. But at least you're going to get that full corridor of movement. Oops. So these are tricky questions, and I just stress that talk to talk to folks that know the landscape, think about what's important for that animal, think about what's important for that landscape, and if that's a true migration corridor or not. The other thing that I wanted to mention here, and let's just disregard that this animal died. For now, I'm going to come back to thinking about what you do when an animal dies, but this part right here, this animal made this start of its fall migration, I think, in 1.5 days. And so one of the big questions that folks often ask is, how do we deal with animals that make the migration in 1 day, or we have very, they do it so quickly that it's not much of data to develop that corridor? Well, basically, that's the migration, and that's the data you have to work with. The Brownian bridge should work as long as I think there's 5 GPS points or so. So what we tend to tell folks to do is, if it's just a 1-day migration, try to grab a couple of days on either end of it, even though it's in the summer or the winter range. And so the Brownian bridge method can actually develop some idea of the motion variance and how wide that heat map should look. And so it's okay to grab some extra data on the end of those quick migrations. Hopefully that makes sense. And if somebody has a question, we can talk a little bit more on that. Okay, so let's just take a quick break, and I think I see some comments coming in. Holly, is there any follow-ups or anything more we should talk about with some of those defining a migration parts?
One question did come in. I'll let you decide if you want to answer it now or later.
Okay.
So Migration Mapper allows the user to map or analyze winter range, but what about critical summer range? How would you suggest depicting critical summer range?
So as currently, you cannot analyze summer range per se with Migration Mapper. But my suggestion to you is you can easily trick Migration Mapper into analyzing summer ranges by simply moving the sliders over the summer range data. And so let's say you could simply identify all those spring sliders. You could slide that over to where your window of summer range data could be, say no for fall migration, and basically you could run the whole analysis just on those summer data. You're just kind of tricking Migration Mapper into saying that it's spring data, a spring migration, but in reality, you're actually identifying the summer area. So that's the way we're doing it now. We have not implemented a summer range specific analysis, mainly because the secretarial and order is focused on winter and migration. And we're trying to balance making Migration Mapper simple enough to do what we need to do, but also simple enough to make it easy for us all to work with it, but complex enough that we can do what we need to do. So hopefully that answers your question for now. If that person has some more discussion with respect to summer range, feel free to email us and we can talk further.
One other question did come in. Cindy asked, similar to that, what is the potential of using Migration Mapper to obtain dispersal corridors between protected areas and fragmented landscapes?
I think that's a great question. I think along the same lines of my previous answer, I think you could easily use Migration Mapper to identify those movements, and thus you're not actually identifying spring and fall migration, but you're identifying movements of your own interest. And so you can move these sliders to catch those movements, and you can do the same exact analysis. So I know it doesn't say, dispersal corridor analysis, but you can easily trick Migration Mapper into doing that. If you just want to call that a spring movement, it'll then do all the other analyses for you. That's a good question.
That's all we've got for now, Jared.
Okay, good. I'll move on to the next little section here. So Another question we really get is about partial migration and animals switching their summer and winter range. And so what you can see here, this is an elk that spent its first winter here, migrates up into kind of a summer range into here, and then moves back down to a different winter range over here. And so I just want to give you a little bit of information about how we think about this with respect to our own analyses. And so the first and the biggest thing is that for this herd or population, we were looking at a corridor emitting from a winter range over here. And so in this case, we only kept the fall migration because we wanted corridors coming from and going away from this winter range. And so in this case, we just disregarded this one because this animal, this migration movement would be better for a herd that's in this area. So that's the first thing we think about is if an animal is switching its winter range, which of its movements are more tied to the herd or the population or winter range that you're focused on for that current analysis. And so you can see here, I basically said no to the spring migration, but yes to the fall migration. So we're going to get this corridor emitting from this area. Another thing that folks have to be really careful about when animals are switching is look at this next square displacement graph. Is very, if you just looked at it really quickly, you would think, oh my goodness, what is going on? It doesn't even make sense. And so when I see this, it makes me think, okay, I need to sit down and really look at the sliders and think about what this animal is doing. And we can see that it starts here, then it moves into this area up here and spends the summer and then comes back. And so that's another thing you have to be really careful about when animals are switching ranges in that case. But those are some of the main things thinking about switching. And if this animal was just moving to a slightly different winter range, just slightly next to the one before, we would probably include both of the migrations going in and out of that. It's just some small drift in its winter range. But in this case, it's such a big difference that we would only include the animals that would only include the sequences or migration lines of interest to us. Okay. Any other questions, follow us up on that? I mean, I understand that in this situation where you have partial migration and switching, there's so many possibilities out there, but I just wanted to give you some of our thoughts and how we think about that.
Jared, I haven't seen any questions come in yet on that specific topic.
Okay.
I've got one minor thing.
Oh, go ahead.
You want to have analysis for a population and other population.
Yeah. Yeah. Let me just reiterate. Somebody from the team here just kind of reiterated the fact that this sequence in turquoise here we would use for the population that's over here. So this animal, this individual animal's data would fall into this population's data and this population's data, but we would only include this migration for this population and only include this migration for that population. I hope that makes sense, but these are the kinds of things that we are thinking about when we're putting these animals in different populations and deciding what to do with this partial migration. Okay, Holly, should we move on to the next question?
Yeah, there's one question. It's not directly related to this, but let's go ahead and take it now. It says, David says, this is great software, thanks. How would you respond to reviewers that think it's subjective and want something more reproducible?
Sure, that's a good question, and I think there is some subjectivity in what we're doing, and I think defining migration routes and defining herds, you're never going to get a pull the trigger and get an answer result ever. And amongst our group, we have come together and decided that a lot of these questions, we make sure we have people on the ground that know the landscape know that population, and we make decisions thinking about being on the ground and whether that corridor or that movement is important or not to connecting seasonal ranges. So I agree that probably from the scientific perspective and getting things published, it's trickier, especially with these animals that have messy movements. But from a conservation and management perspective, to me, we have a situation where we can easily decide as a field team or an analysis team, that movement between these two areas is important for this population of this individual. And we can make that decision and we can move forward. And I think it's justifiable from that standpoint. So good question. Yeah, there is some subjectivity, but I think when we put our biologist manager cap on, I think decisions can be made about these things.
All right, thanks,
Any
Jared.
others,
I
Molly?
don't see any other. I don't see
Okay.
any others for now, so I think you're good.
Okay. Okay, so the next thing is the question, how many individuals do I need to make a useful corridor or winter range? And this is the question that was asked earlier, and so let's dig into this now. And so, like I said earlier, this depends on a number of things. We don't have a number for you that's going to help you, but the first is you need to think about if you actually want to know where 20% of your population goes, you need to have a sample size that can represent what 20% is. And so, like I said before, if you only collared 10 animals, 20% is 2 of the 10. And do you really want to make a recommendation for policy or management or conservation based on 2 animals? And so that's the first thing I'd like to say is think about what it takes to get to a high use corridor. So in that case, you know, if you might think, well, might want to have 40 animals. And so at least the 20%, the high use corridor might be based on 8 individuals. And so just to kind of give you an idea, like that 40 number, we tend to pass around quite a bit. But it also depends on some other things. So the first is the spread of the winter range. And so if you, let's imagine that these animals in orange here were all kind of one similar winter range, we have them spread out. And so a lot of animals are emanating from a lot of different spots. And so what that means is that already we have the population is split into kind of 3 different main corridors. And so for us to identify a corridor that's 20% of the population, it's going to be harder to detect that with a lower sample size because there's so many areas that the animals emanate from this larger winter range. Now, in this case, in the blue, much smaller winter range, it's going to take a little bit smaller sample size to start seeing these main corridors pop out from that area. And so that kind of dovetails off of the idea of how many different routes does that population use. And like I said, if for a given population or herd it uses a lot of different routes, you're going to have a higher sample size to discriminate what the high use and a low use area. But if most of the population uses one route, so like let's just look at this, let's imagine that this middle corridor is one wintering population. It looks like with just 10 animals, we might be able to identify this main route that they use. So hopefully that gives you an idea of how many routes, spread of the winter range. And then another thing if we look at the blue population here, we can see that, yeah, there's kind of a general area that they use, but you can see there's quite a web or network of corridors in here. And so when you see this kind of thing and it's not all clear, tight corridor bottleneck type areas, you'll need a bigger sample size in order to reveal what areas are more and less important. And just for some rule of thumbs and just to kind of give you guys some of our results, that we have done some corridors with as little as 20 animals in a population, but that is probably a minimum, and probably you're kind of approaching on pretty small population size. And I'd say that the vast majority of our corridors are based on populations or herds where we have over 30 or 40 animals collared. Pretty along those lines. So unfortunately, I don't have just a number for you guys, but I at least want to bring up these thoughts. And when you're seeing your initial data and maybe deciding whether or not to do a phase 2 of collaring effort, these should help you make that decision whether you think you need some more data to develop a good understanding of the corridors or not. Yep. Oh, yeah. Yeah, I'm going to say maybe. Holly, is there any questions on this? This question?
No, I have not seen any questions coming on this.
Okay, and so before I move on, something was brought up as a follow-up to that subjectivity versus objectivity issue, is that everything that's done in Migration Mapper is spit out in the files, and so you can see you have a CSV of every start and end of migration that you chose, every Browning bridge that you made, and so everything is transparent and out there, and there's very little that's going on in Migration Mapper that does not get spit out, so you can see what's happening. And so just to kind of follow up on that question, at least everything is transparent and you can look at these things and talk about them and make decisions in that sense. Thanks for bringing that up. Okay, so the next question that we often get, and this is a very important one, is what do you do when an animal dies in the middle of a year or in the middle of a migration even? I just want to tell you guys some of the thought processes we go through when making that decision of what to do with that animal. So the first question is, if it dies and you see a big movement to one place, so let's say in this case you saw the animal move up to summer range and then it died on summer range, first question you need to ask yourself is this a migration or was this a dispersal event? And so that's a thing, and if you want to include dispersals in your migration corridors, fine, but for our typical definition of migration, you need to think about if it dies on summer range and it's the first year of data that you collected, is that a representative movement between two ranges? So that's one question that we think about. The next thing I want to bring up is if the animal dies in the middle of its migration, we tend to not include that migration in the analysis. And the reason is here's a case that this animal started going back to winter range, spent a couple months on this stopover, and then died before it got back to winter range. And so if we included just this movement, you'd basically be biasing towards a higher influence of this part of the corridor and lowering a lower bias on this part of the corridor. And so you should tend to not include sequences that break in the middle, because then you have kind of a lopsided heat map or even footprint for that animal's migration. So that's a big thing that we think about, which tends to make us throw a sequence out that is incomplete. And that can be, just to kind of go on to a little different part, that can also have to do with if the caller switches or starts to fail and the data quality changes in the middle of the migration, we would tend to want to throw that migration out, especially if we have other migration sequences from that individual to use. So anyway, keep that in mind, that if you have an animal that dies in the middle of migration, you're going to bias that heat map and the footprint of that migration because it died halfway through. And then the biggest thing that we think about when we're deciding whether to include or not include a sequence is, does this animal have other sequences that we could use that are a good representative of that animal's migration route? And so again, we go back to, does this animal, let's say it was collared for a year and a half and then it died. We can maybe go back to the previous year of data, kind of get a feel, is it using the same or pretty similar route? And if it is, our suggestion would be to use that first year of data and just do the migration routes from that year of data, and then throw out the second year where it died. That's going to keep the sample size balanced for that individual and not have these broken footprints and heat maps. Those are probably those are the main things that we think about when trying to decide what happens when an animal does die in the middle of the year or in the middle of a migration sequence. Any questions? Any questions coming out on that, Holly?
No questions yet on that.
Okay. Okay, so, I guess this is kind of a follow-up on that same question. So what if data quality or fixed frequency changes within a year, even within a migration sequence? I just said that. Maybe I'll just reiterate it a little bit here. So in this case, you can see that this individual in its spring migration has really, the collar was having a tough time. I think there's only 1 or 2 points being taken per day. And so usually we would just throw those out, especially if there's another migration sequence, because when you get data like this, you're going to get this huge blob of where the animal could have gone, because if it's an elk, especially for any 12-hour period, we know how far an elk could potentially go between any given points for 12 hours. And so the kind of heat map of where the animal goes or potentially could go is a big, wide heat map. And so you want to avoid those data when the collar is not doing well. And we're going to talk about this collar frequency issue and recommendations just a little bit, but I just want to mention that. So in this case, we would not do this, but we would keep the fall winter range. What's unfortunate about it is this animal uses what looks like a different migration route in spring versus fall. And so because we had to remove this one, we're not going to have this spring migration represented for this individual, which is unfortunate. And again, this is just to remind me to tell you that when you zoom into the spring or fall migration, you can see these dots, and that can help you decide, is the collar working properly and very well? And so when you're seeing lots of dots per vertical line, that means the collar is collecting quite a few points a day and that you're comfortable with those data. But if you see some of these vertical lines with only one dot in them, then the collar might be malfunctioning and having some problems. So I just wanted to bring that up, that you can see that right here in Migration Mapper. Okay, so let's move on to this other question about the best fixed frequency for corridor and stopover analysis. So based on our analyses that we've done here in Wyoming, and also that we've seen in other states and working with other folks across the West, it appears that if you want a nice, tight, clear corridor analysis, you need 1 to 2 hour relocation data for elk and 2 to 3 hour relocation data for mule deer. That's our recommendation for the best practices. And the reason there's a difference there is that elk generally move more or move faster, and so it's harder to kind of identify a main corridor. And so I just gave you an example here. This is an elk that's collared with 1 hour data, and this is an elk just next to it collared with 3 hour data. And so you can see that the width of that footprint in the heat map can double in size just based on different collar frequencies. And so this is kind of a best practices numbers. If you want a nice tight corridor, these are some of the values that we would suggest putting your collar to take locations at those levels. Now, that being said, I just want to tell you guys that we have done elk corridors with 3 hour data. They're usually wider and a little blobbier looking, if that's a word. I just made that up. We've also done mule deer corridors with 5 hour data. Again, they're a little bit wider. We've also done some pronghorn corridors with 3 to 5 hour data. And so these are kind of, I would say, the upper limits to if you want to make a decent map of high use corridors and stopovers. these are probably some of the upper limits for your collar data. And this is what we would recommend. So now the next thing I want to show you, just to kind of reiterate this idea that, you know, elk have this bigger movement kind of propensity that kind of creates this bigger blob. And so one question we often get, and we even see it in our data sometimes, especially if the collar is malfunctioning or if you have an animal that is moving very fast, you get what we call the BBM, or the Brownian bridges are blowing up. And so if you ever see, you know, one corridor that looks pretty nice like this, and then you see something, another animal next to it has this really huge, what we call blobby look to it, that's a red flag to you that there's something wrong with that individual, or the collar was not working very well, etc. And what's nice is the Brownian bridge method spits out this thing called the motion variance. And that's just a number that tells us how wide these footprints should be between any 2 points. And so when the Brownian bridge motion variance is really big, it means that the animal could have gone anywhere in here between these 2 points. Oops. And the method is having a tough time identifying where it went, or at least it has more error or more uncertainty in where it thinks the animal went. And so when you see blobs like this is likely meaning that the motion variance of the Brownian bridge is really big and it has no idea where the animal is going between 2 successive points. And as a general rule of thumb, we have been removing individual sequences that have a motion variance greater than 8,000. And I think you'll see that that number seems to be working pretty well for removing these animals that have these big blobs, while also kind of keeping it so we're not throwing out a lot of data. And so just so you know, if you have a collar that's, let me just ask a question to the group here. If you're doing 12-hour data for Brownian bridge, are all the motion variances really big? Or does the motion variance stay?
Well, depends on
the
speed of
movement. Okay. Okay. So it really, the motion variance really has to do with the individual animal, how fast it moves, and how linear its movements are. And so when you have an animal that's moving in circles and moving really fast, you're going to get this blowing up. And so in Migration Mapper, there's this migration table that has the dates, and it also has whether the Brownian bridge was successful and everything, and it has this motion variance in there. And so you can go into the Migration Mapper file once you've run the Brownian bridges, look at the motion variance for each Brownian bridge, and maybe plot some of those individuals and see, with a very high motion variance, should we even include these? Are these animals even providing us useful data for this corridor analysis? Okay, the last thing we're going to talk about is kind of on the same idea here is life cycle collars. And one of the biggest things is a lot of folks in the West have put the life cycle collars out on ungulates. And so the biggest question is we would like to be able to use these collar data to make migration corridors. And so the kind of initial answer that we've always given years ago is, oh, you just can't do that. But now we're realizing that there is so much untapped data that should be used to make migration corridors with these 13-hour data. And so I just want to tell everybody that we're working on this right now. I don't have any final decisions for you, but I'm just going to give you a little bit about what the different methods that we're trying and a little bit of the results, and just give you an idea that probably we're going to be pretty close to done with this, maybe within a few months, maybe towards the end of the summer. And our plan is to update Migration Mapper so you can actually put your 13-hour data in there. And so here are the options that we're considering with how to analyze 13-hour data. And let me just back up for just a second. So the Brownian bridge movement model is built on the idea that we have fine scale data. So the idea is that the most likely movement between any 2 points is generally a straight line, and that's probably the animal went down that line, maybe with some error around it. But when you start getting into data that are 13 hours apart, that kind of assumption of that animal spent the time wandering along that straight line is probably getting violated pretty strongly, because the animal could have gone anywhere in 13 hours. And so I just want to kind of to set this off as there's an inherent issue with 13-hour data in trying to identify a corridor or some movement, the actual line that the animal used. So I just want to preface that. And so all the methods that we're looking at are basically small little tweaks to current methods to kind of try to sidestep some of that assumption that animals we have fine scale data and that they move in a linear fashion between those points. And so here are the options that we're thinking about. And so the first one is obviously you just do the Brownian bridge on the 13-hour data, but most people that have seen this, you'll realize that the footprints are just huge. I mean, it's multiple miles wide, and it doesn't look very good, but that's kind of where we're at if you did this with regular Brownian bridge. The second method that we're using is to simply force a smaller motion variance on the Brownian bridge with the 13-hour data. And so basically what we're saying is that this animal, we have less error, and we know that the line, or we kind of have this idea that near that line between any 2 points is the most likely area, and we can shrink down that motion variance and just get a tighter corridor from the Brownian bridge by just forcing that motion variance to be smaller. And remember, the motion variance is basically how much error there is between any 2 points. And so we've developed some equations to estimate kind of an optimal value for each species. And I'll show you the results in a little bit. And it seems pretty promising that we can actually shrink those motion variances down and get a pretty good corridor out of it that can be compared to like a corridor that's made with 2-hour data. The next method that we're using is this continuous space, continuous time stochastic movement model. Pretty fancy name, but basically what it's doing is it takes into account the idea that there's a correlation in animals' movements, and so for any given point, any given line between 2 points, it takes into account that the previous step was going at a certain angle. And so this is a little bit different method to kind of develop the footprint and the heat map of where animals go, and we've been trying this method as well. And then the final method that we're looking at is quite simple, very understandable, but probably least scientific, and that is simply taking all the migration lines and just buffering them by a specific amount, and then merging them together and stacking them up for the footprint. Now, what's different about these methods is that the first 3, we could still calculate stopovers with them, but this last one will most likely only be for calculating the corridors, because all you're doing is you're removing the time component of where the points stack up. You're just making a buffer around the lines between the points. So I'm going to show you some initial results that we have from these methods and what we've been doing on our end. So this is just a really simple graph here. On the left-hand side, we have the Brownian bridge, the regular Brownian bridge method on the 2-hour data. And this is just some corridors here. Winter range is on the north, summer range is on the south. And so this is kind of the typical thing we might get with regular Brownian bridge. We get a few corridors here, and this is just kind of the medium use corridor. Now, if we do the Brownian bridge on the 13-hour data, then boom, you have this much wider width to the corridor. So this black line is representing the Brownian bridge medium use corridor with the 13-hour data. And then the gray inside here is the gray you see from the 2-hour data. So you're seeing we're like doubling, in some cases even more than doubling the width of that corridor using those data as they are. And also we see that we lose some connections here. So because we chopped out a bunch of data between the 13-hour points, you can lose little connections like this because there was a point here, and then 13 hours later there was a point here, and they zipped through here really fast, and so it didn't kind of get caught up in the high use migration corridor. Then using this fixed motion variance, where, like I said, we identify a motion variance for each species based on how fast that species moves and how linear its movements are, we can actually force a smaller motion variance on the 12-hour data. And as you can see here, that tightens that corridor back up. And so this is a pretty promising method that we're working on, and we're trying to tease apart the kind of the quantitative results of, is this method doing a good job or not? Like, how much overlap is there between the regular 2-hour data and this forced motion variance? And so that just gives you a little idea of what we're looking at with these methods. And then I wanted to show you this line method as well. And so on the left here, we just have a map of the regular BBMM on the 2-hour data. And so this is the footprint. So this is where all the animals go. And then blue is the medium use. And on the right here is the same 2-hour data, but this time, instead of running the Brownian bridge analysis, we simply buffered those lines by 200 meters on each side of the line and did the same exact migration corridor analysis. And what's promising about this is, indeed, we kind of get the exact same 2 high-use corridors coming out, and they're a little bit thinner, a little bit tighter, as you might expect, because we have this 200-meter buffer. And you can see that for a given individual, the 200-meter buffer is much smaller than what the Brownian bridge tells us is the footprint. And so we're tightening that up. And so this method is also very fast, but it also has the issue of how do we define what that buffer is? So anyway, I just wanted to give you an update on where we're at with working on those. We have about 7 data sets that we're testing all these methods on, and we'll have some updates within a few months on that down the road. And that's really the end of what I had for you guys, and hopefully we have a little bit of time if there's some questions to finish us up.
Hey, Jared, yeah, a question came in about CTMM, the end here, from Franny. She asked, is the CTMM model akin to the continuous time correlated random walk that Devin Johnson implements in his package crawl, or are you using an alternative model?
Is anybody here that can answer that question? I cannot answer that question, but tell Fran to please email that question to one of us, and we can get it answered. I'm not sure exactly. I'm not thinking that.
Oh, did I not mute? I can actually answer that one. So it is a different model. Exactly how it's different, I can't get that specific, but the Devin Johnson model takes a drift coefficient, and there's a number of different parameters, but it's not the same model that's implemented in CTMM.
Okay, good. Any others, Holly? And we can just, if there isn't right now, we can wait just a little bit and see if folks want to type in a question, and you can bring it up towards the end here.
Yeah. Yep. Maybe I will jump back to a question that we had earlier that was a more general question. Okay. Perhaps Matt wants to take this one. This is from Neil, and Neil asked, wait, hold on just a sec. With the cattle and beef growers lobbying entities opposing the integrity of the migration initiative, will this information be provided to congressional bodies to help them better understand the credibility of this project?
What was the first part?
With the cattle and beef growers
Say it again, I'm sorry.
No, that's okay. With the cattle and beef growers lobbying entities opposing the integrity of the migration initiative, will this information be provided to congressional bodies to help them better understand the credibility of this project?
Yeah, so, this work is technical in nature. So, the work of the corridor mapping team is to assist states to map corridors. So, that, akin to how different states have tackled other technical challenges such as winter range or population modeling or siteability analyses. So that's the way we view the work of the corridor mapping team. It's just is working to help states overcome the technological hurdles of doing the mapping work, given what kind of data they have and what kind of data they might put out in terms of new callers. And then, so we view that as, what the states decide to do with their corridors with respect to management and best practices is a separate issue from the mapping. But certainly, any of this data that can be made available to any stakeholders.
Great. Thanks, Matt. And I don't know, Neil, if you want to follow up, feel free to do that. I don't see any other questions right now, Jared.
Okay, well, we'll give it a couple more minutes. If there are any questions, we can finish up.
Feel free to unmute yourselves and ask a question, this sort of end part here. Anybody's welcome to do that.
And my email address is on the Migration Mapper website, and if there's any questions, you can email me. Also, the Wyoming Migration Initiative, there's a contact section in there, and you can, depending on what the question is, if it's more technical, Matt Cruz-Acrio and myself. If it's more management policy related, maybe Matt Kaufman or others. But yeah, we're happy to take emails and questions outside of this session as well. We can't guarantee a quick response, but yeah, we're happy to take those questions. Yeah, and this whole thing that we've done here has been recorded, and when we're done and we get everything organized, we'll provide that link, and folks can pass it around and watch it again or zoom in on different parts. So keep that in mind as well.
Great. A couple of thanks coming in from the chat. Thank you all for that. Really appreciate it.
Yeah, you're very welcome.
All right, well.
If you want to
maybe
close it up?
Yep, I think people have had ample time to ask questions if they wanted to. So, and we had just for your information, we had up to 75 people at one point. So.
Okay, good to know.
We did get a question about how they will be notified when the recorded version is available. We'll send out an email, I presume.
Should we put a link on the website, maybe?
Yeah, we'll put a link on the website. We've been communicating with a lot of folks through Heffelfinger and the Mule Deer Working Group, so we'll definitely send it out there. And then, don't you have a mailing list for Migration Mapper?
Yep. Anybody that's downloaded Migration Mapper, we will send it to that list as well. Good.
Well, thank you, everybody, for joining us.
Yep. Thank you very much. Have a wonderful day, and we'll see you later.
All right. Thanks a lot, Jared.
Yep.
Nice job, Jared.